do, students? This is Miss Green, and we are starting 7.6, translating trig functions. We're going to be looking at the graphs of sine and cosine functions and what happens when we shift them up, down, left, right, and also some other interesting things. I found this quote, and I thought you might think it's interesting. We keep moving forward, opening new doors and doing new things because we're curious, and curiosity keeps leading us down new paths. Do you know who said that? If you said Walt Disney, you're correct. The learning target for today, day 1 of 7.6, is using the transformations to analyze trig functions and their graphs. We've done transformations before. Something interesting happens when we do certain transformations with trig functions, such as a sine function. If you want to look at this in Desmos, it becomes quite interesting to look at these and compare them in Desmos and see what happens to the horizontal. We know that when we change x, subtract or add something to x, and then we do the function that we're looking at here, 2 times the sine of that, we know that it will affect the left-right movement, the horizontal movement of it. So go ahead and try Desmos. Type in y equals 2 sine of x. And notice on your settings in Desmos, you want to make sure you're in radians and not degrees. If you think about looking at a graph that had degrees, for it to go through a whole cycle, it would have to be 360, which would change my view here of the x-axis. So want it in radians, so then we only have to go up to about 4 pi, and we can get a couple cycles going on usually. Now, y equals 2 sine parentheses x minus h. Hit the h and you'll get the slider, and you can change that slider. So look what happens when I make it larger. So from the movement, you can see that if I make it smaller, it's going to the left. So I'm subtracting a smaller. Here I'm subtracting negative numbers. So what am I really doing? And here I'm subtracting a positive number. Look what's happening. So notice how it's moving. What happens when I get it? Let's do about, what is 2 pi? About 6 point, ooh, look at that, 2 pi, it's right on. So it's exactly on it. If I just moved it 1 pi, 3.1-ish, look at that fun little diagram. All right, so take some notes there about what you observed. Make sure I get them. I have 2 of them open. Yeah, so what happens as the h got larger, it moved to the right, and as h got smaller, it moved to the left. And what else did we notice? We noticed for this one at 2 pi, it was the same graph, right? And if when I did it just at pi, when h was 2 pi or h was pi, I've got how you would want to describe this, but I got this kind of shape there. So that was kind of cool. Did the amplitude change? No. Did the period change? No, because at 2 pi I got the same graph, right? So that none of those changed. And here I just drew a picture of when I had h equal to 2.1. I noticed that it moved to the right. 2.1, the y value. Well, it moved to the right. Yeah. It shifted to the right. And then this is called a phase shift. So that's the definition of a horizontal translation when it comes to periodic functions. Phase shift. We noticed how those lined up too. Well, now I'm going to look at how the period is affected by what I put in front of my x. So I've kind of already done this one. Now I'm going to look at y equals sine of bx, this one right here. What happens when I change the b? Let's look at that again by looking at Desmos. And again, you can do this on the TI, but it's a little simpler to do. Well, I like it because you can see the equation and you can see the graph at the same time. And you can have this slider, which you can't do easily. There we go. So why don't we just make this one the sine of x so you can see. There we go. So now I'm going to add the slider. And when b is 1, I have the sine of x, right? So I have the same thing. Now look what happens. When b is greater than 1, I'm getting more and more cycles in. So my period is shrinking. So from here to here is 2 pi, but look how many cycles I have for the red one. I have a lot, right? Because I've shrunk those cycles down. So now I have more cycles in the same period that I had before. Now look what happens. Let's make it really negative. Same deal, right? Okay, let's do fractions. Let's go from 0. Oh, look at that. 1. How about a half? Let's see if I can get to a half. What happens? Wow. Okay, I think I'm going to scoot this over just a little bit. See if I can see that full period from 0 to a little more than 12. If you looked at pi, you would notice that 4 pi is about 12.4-ish, so about right there. So now when the b is a half, that means I only have half the cycle that I had previously. That's what that's telling me. I only have half the cycle that previously had in the 2 pi. So on the purple one, that's the original sine function. After 2 pi, I've gone through a whole cycle. But when it's a half in front of the x, before I take the sine of it, notice it gets to 4 pi. So the period gets bigger as the b gets fractionally smaller. Let's write some of our observations down here. So as b is greater than 1, b increases the period. Oh, no, I wrote that. It's like, what did I just say? No, as b increases the period blank, it decreases, right? We saw that. The period got smaller because I got more cycles in the same amount of time, if 2 pi is the time factor, the x-axis. So between 0 and 1, and that would, the period would increase, right? This is kind of backwards from what we're used to thinking. We can also remember that the period is 2 pi divided by b, or it could be written as the period is 2 pi times 1 over b. And that's when we look at sine of 2x, then the period would be 2 pi divided by 2, which the period would be pi. So it would be smaller. So the period would decrease. Let's look at this one and think about what we've learned about how we're changing functions. When we look at this value right here, we learned that that's the absolute value is the amplitude, so that would be 3. And the period, remember, we look at whatever's in front of the x, so b is 1, and we take 2 pi, so the period, sorry, I should have written this out, 2 pi times the reciprocal of b, which that's 1 over 1, so it really doesn't change, right? So that's 2 pi. And then the phase shift is plus pi over 4 units. Do you want to check that out to make sure? There'd be units. Plus is always to the left. And you can graph on Desmos just to double check. So let's go 3. Let me double check the equation so I didn't remember if it was sine or cosine. 3 cosine parentheses x plus, and then the pi is on the keyboard for Desmos. You can go down there. You can't see what I'm doing, but it's down there. Pi divided by, whoops, divided by 4. And then why don't we get rid of the slider here and let's just graph 2 cosine x. So you can see the difference. So the red one is it shifted pi over 4, and you can look up here too, see how it goes negative pi over 4. So it went to the left for the x values, horizontally moved to the left. So it looks like we did it correctly. And if you wanted to check, you could try doing y equals 2 cosine x minus pi divided by 4. You could just see how that affected it. Oops, I spelled cosine wrong. There we go. And let's change, we could change it. Well, you can see that one. Kind of wish that it was a thicker line there. It moved it this way. Right there. Okay, so have a little fun with that. If you just have some time and you just want to investigate a little bit, I would go through some of that and try some different things. So I like to be able to do this before I graph and then check it with Desmos. So now I have nothing in front of there, so the amplitude is just 1. The period is 2 pi divided by 3, because divide by the b that's there. And then the shift is 3 pi over 4. And because it's a plus, it goes to the left again. And you could graph that on Desmos. I'm going to save you a little time, but you could graph that on Desmos to see how that looks. If we're wanting to graph the sine or cosine of a function with a phase shift and maybe even a vertical shift, we could do it by getting some remember when we did one of these things and we did a little bit of a point here, point here, point here, and a point here, and point here. So we could put those x's in and then kind of figure out what the y would be that would go with each of those. Let's start by just looking at the basic. Y equals the sine of x. So this is my parent function. The period is always 2 pi, the amplitude's 1, there's no horizontal, there's no vertical shift. Now on this one, the period is just changed, remember? It's 2 pi divided by whatever I have in front. Well, I'm dividing by 1/2, which means I'm multiplying by 2, so now my period just got bigger. The amplitude, again, I have nothing in front of here. I'm not adding or subtracting anything, so those are just like that. Now this looks almost the same, except the amplitude, and then, oh wait, I changed this and this. So the period would be the same though, because I'm still dividing by 2, so I multiply by 2 and I get 4 pi. Oops, yeah. Oops, what in the heck? Okay. Didn't know what that's all about. The amplitude is 2. Okay. Push a little button here and then magical things happen. So the amplitude would be 2. The phase shift, I'm not adding or subtracting inside what there would be kind of invisible parentheses there. So there's no phase shift, but I am shifting it up 3. So this is how, after I do the sign and multiply by 2, then I added 3 to everything. So that's a vertical shift. This is the part that makes life interesting right here. If I wanted to graph by hand, I could do this without the shift. I would probably, I'm going to just start by doing the sine of x, 2 sine of x plus 3, just kind of making my life a little easier. So the period's the same, the amplitude is 2, and then there's no horizontal, and then I would vertically shift everything up 3. So you might want to do this to be the sine of x, and this 2 sine of x plus 3. This might make the graphing just a little bit easier. I didn't write that correctly. Make that in there. So remember the sign of 0 is 0, because in the unit circle, when I'm here, that's 0 or 2 pi, right? And then when I'm over here, that's pi. And then this is pi over 2, and this is 3 pi over 2, so 1.5 pi. And you can just look at the coordinates, whatever the x coordinate is here. So this is 1, 0. Whatever the x coordinate is, that is my cosine. And then this y coordinate is the sine. So the cosine of 0, when the angle is 0, my sine would be 0. When the angle is pi over 2, so it's going straight up, my sine would be the y value, and that would be a positive 1. And then the sine on pi would be 0. This would be negative 1, and then I'd go back to 0 again. And this is my period, so then I just repeat after that, 0, 1, 0. So I could graph those on here if I wanted to, just the sine function. Now I'm going to take every one of these values, multiply it by 2, and then add 3 to it. So 2 times 0 is 0 plus 3, I'll put it under here, is 3, right? 2 times 1 plus 3 would give me 5. 2 times, sorry, I was just thinking, 2 times 0 is 0 plus 3 would give me 3 again. So you can kind of see a pattern, right? And this would be 2 times a negative 1 plus 3. And that would give me positive 1. And then I put 0 back in and I get. So I'd go ahead and graph this. 0, 3, 0, 3. And then pi over 2, 5. Pi over 2, 5. And then I've got pi 3, pi 3. And then I've got 3 pi over 2, 1. 3 pi over 2, 1. And then I'm back to my 2 pi again, and I know I've done one period. So I'm back. So I've gone up, down, past the midline, and back up again. And it would keep doing that, right? Be a little more rounded than when I drew there. So you can see that the midline has changed to here. And you can also see wanted to show you something here. If you if you know the max and min of your y values, to find the amplitude, you could just subtract those two and divide by 2. Subtract the max and the min, make sure it's positive so it'd be the absolute value, and then divide it by 2. 4 divided by 2 is 2. So that's your amplitude. It's just a little trick there. Now on this one, this one was 2 sine of x plus 3. This is 2 cosine of x plus 3. Again, the period's going to be 2 pi. The amplitude is going to be 2. There's no shift. There is a vertical shift up 3. Now this one, just wanted to do it so you could see the difference between the cosine and the sine. This one, at 0, the cosine is 1. So think of your unit circle again and think of the x values at these different places. So the x value right here is 1. And then when I multiply it by 2 and add 1, I get the 5 here. The pi over 2, the x value is 0. This is a 3. At pi, the x value is negative 1. So you get the 1. And then 3 pi over 2, it's 0 again, and 3. And then we start repeating because we're back at the beginning. Oops. Yeah. Okay. 1, and you get the 5. So we've done everything the same except now we're doing the cosine function. So we have at 0, we have 5. At pi over 2, we have 3. At pi, we have 1. We go back to 3. Go back. Oops. Yeah. So it's kind of doing one of these things. Right? Let's look back at the previous one again. What's different? So this one started out at 3 on the midline. This one started out at 5. The midline's right here. Okay, I hope you're able to gather a little bit of information from there. The best way to become familiar with this is just graphing them. You can use your calculator or you can use Desmos when you're just trying to compare. Desmos works really well because you can see the functions, and then when you're trying to do some solutions that we'll do a little later on, your calculator is important to use that too.